Welcome everyone, I'm Adam. And in this problem, we're going to be solving the equation cosine x plus 1 equal to negative cosine x. Now, the initial steps in solving a trigonometric equation are generally the same that you would do in basic algebra. For example, if we look at this, we see that we have a quantity, plus 1, equal to negative that same quantity, where cosine x is a varying quantity, or think of it as a variable. So to start with, solving this equation is going to be much the same as attempting to solve something like this from algebra. Say y plus 1 equals to negative y. So if you remember the steps that we would do here, we have an equation with a single variable. We're going to isolate the variable on one side and bring all constants to the other. So that's what we're going to do here to start. So taking a look at our equation, we're going to isolate the cosine x on one side. Say we'll bring it to the left. So we're going to add this cosine to both sides so that the cosine and negative cosine cancel on the right. And that's going to give us, say, 2 cosine x plus 1 equals 0. And next, bring our constants over. So subtracting 1, giving us 2 cosine x equals to negative 1. And then lastly, to get cosine by itself, we'll divide through by 2, leaving us with cosine x is equal to, say, negative 1/2. So we've solved this for the trig function cosine, which is equal to negative 1/2. But solving the equation is solving for what values of x make this equation true. So x represents our angle, and we want to know which angles that plug into cosine give us values of negative 1/2. Now there's two ways to do this. You can look at the graph of cosine, or we can look at the unit circle. So we'll do that. So let's take a look at our unit circle. Starting with our origin 0, going distance all the way around 2 pi, and ask ourselves, or do a little bit of review, what values or angles give us cosine values equal to negative 1/2? And if we think of that, well, cosine equal to negative 1/2, we know one of the angles is 2 pi over 3, where the point is negative 1/2 positive square root of 3 over 2. And the other angle is 4 pi over 3, where we have point negative 1/2 negative square root of 3 over 2. So what do we do with this? Well, first off, when we're trying to solve the equation, if there's no restrictions on the angle, then that means what we're looking for is a general solution. Meaning, if we were only looking for angles, say, between the 0 and 2 pi, then 2 pi over 3 and 4 pi over 3 would be good enough. But we're looking for all possible angles. So what we're going to have is the angle x equal to 2 pi over 3. But the general solution for that is noticing all possible angles. Meaning, if we look at 2 pi over 3 and notice that if we go around the unit circle, all the way around, a distance of 2 pi, we get another angle, namely 2 pi over 3 plus 2 pi. And I can repeat that process again, or going in reverse order. So the general solution is going to be x equal to the angle 2 pi over 3 plus all multiples of 2 pi. And how we represent that is simply taking 2 times n times pi, where n represents an integer, meaning a positive or negative whole number. So things like negative 1, 0, 1, 2, etc., on to infinity. And our remaining solution is x equal to 4 pi over 3. The same thing though. Taking 4 pi over 3, noticing if we go around the unit circle a distance of 2 pi in either order, we get continued solutions. So the general solution is 4 pi over 3 plus, again, all multiples of 2 pi or 2n pi. So to solve the equation cosine x plus 1 equals negative cosine x, we first isolate the trig function on one side, equal to which value, and then we wrote the general solution for that angle x, which gives us cosine values of -1/2. Thank you very much.